Process walkthrough. Wastewater from camp communities flows to on-ground collection tank. These tanks come with two pumps, both controlled by level switches mounted inside these tanks. The sumps come with a control panel that controls the pumps based on signals received from the level switches. The first level switch triggers the first pump, and the second level switch triggers the second pump. The third level switch sends out a high-level alarm signal. The purpose of this large collection tank is to collect the sewage that flows by gravity from the camp and even out peaks that exceed the equalization tank's capacity. Wastewater from communities that are further away from the main camp can be collected in sumps and be pumped to the main MBBR unit through flexible hoses. Though the sump is smaller than the collection tank, its internals are similar to the collection tank. For communities that are more than 500 meters away from the main camp, the wastewater is collected in sumps and transported to the main MBBR tank with the help of a trailer-mounted tank. This tank is similar to the on-ground sump tank with the same internals and can be towed with a vehicle. Once this tank is close enough to the collection tank, it is connected with the help of a flexible hose to the MBBR tank, and the wastewater will be pumped into the collection tank. The wastewater is pumped from the sumps and collection tank into the main MBBR tank through a flexible hose. There are coarse and fine screens above the equalization tank to remove coarse and fine materials that may damage process equipment downstream. These screens require periodic manual cleaning. The screened wastewater drops from the screening box into the equalization tank. Air is provided to the equalization tank to keep the raw sewage aerobic and well mixed. Air diffusers and air blowers provide the air required. Two submersible pumps are installed inside the equalization tank. These pumps produce consistent flow rate to the downstream biological treatment process. There are 4 level switches in the EQ tank: low level, level 1, level 2, and high level. Low level will turn off all pumps so pumps do not run dry. Level 1 turns on one pump. Level 2 turns on second pump. High level initiates and alarm. Both pumps run together until level drops to level 2 again, and only the lead pump continues to run until it is stopped by signal from the low level float switch. The lead leg pumps are alternated for each cycle. These pumps transfer the screened influent to the anoxic tank. A vertical mixer is provided in the anoxic tank to keep the mixed liquor in suspension. Return sludge from secondary clarifier mixes with the raw sewage in the anoxic tank. Also, a portion of the mixed liquor in the aeration tank is returned to the anoxic tank for denitrification. In the absence of oxygen, the bacteria break down nitrates and nitrites generated in the aeration tank to oxygen and nitrogen gas. This process is known as denitrification. The oxygen is absorbed by the bacteria in the return sludge. The bacteria uses the raw sewage as a carbon source, food for metabolism and growth. And with low dissolved oxygen, typically less than 1 milligram per liter, the nitrates and nitrites are used as an oxygen source for the bacteria in the mixed liquor. The wastewater then flows to the aeration tank. The aeration tank and anoxic tank are connected through a perforated opening at the bottom and middle of the wall between them. This perforated opening is required to retain the plastic media in the aeration tank. The aeration tank is the heart of the biological process, where BOD removal and nitrification, conversion of ammonia to nitrate takes place. Mixed liquor is continuously recycled back to the anoxic tank with the help of an airlift. The flow through this airlift can be controlled by adjusting the opening of the air supply valve. Aeration is provided using stainless steel air diffusers. Side channel blowers with 100% redundancy supply the required air to the air diffusers. Almost half of the aeration tank is filled with biomedia to increase the biomass population in the aeration tank, thus reducing the required footprint. The biomedia is made of polyethylene and has 850 meters squared per cubic meter surface area that houses many different kinds of microorganism population needed for the wastewater treatment. To ensure that the biomedia stays inside the aeration tank, a perforated screen is used to retain the biomedia and transport the mixed liquor and the solids that slough from the biomedia to the secondary clarifier. The biomedia has a density slightly less than water and will float in water. The aeration system causes the biomedia to be mixed into the water and supplies the required amount of oxygen the bacteria needs to grow and thrive and consume the organic waste coming with the wastewater stream. Mixed liquor from the MBBR aeration tank flows by gravity to the secondary clarifier. The flow from the aeration tank is directed to the bottom of the clarifier tank. This manifold includes an air vent and provision to introduce settling aid chemicals if needed. As the water flows upward, the sludge settles on the hopper plates and slide downward and into the bottom of the hopper. It is in the clarifier that the influent stream is separated into water and sludge. The mostly solids-free water rises to the top of the clarifier and out the top of the weir to the next treatment stage. Most of the suspended solids settle in the clarifier, leaving behind clear water. A small amount of solids pass through the clarifier, which is then filtered out in the next stage. The scum that accumulates on the top of the water in the clarifier is skimmed off with the help of a baffle trap installed prior to the weir. The sludge settled at the bottom is transferred by airlift back to the anoxic tank. The flow through this airlift can be controlled by adjusting the opening of the valve. A portion of the sludge is wasted into sludge holding tank as required by closing the sludge recycle valve and opening the sludge wasting valve. Periodically, this scum is removed from the clarifier and recycled back to the EQ tank when the butterfly valve that controls flow out of a small scum box at the top of the clarifier is opened. The clarified water flows by gravity over a weir into the alum dosing tank. Alum, or an equivalent, is used as a settling aid in the alum dosing tank to enhance settling and encourage flocculation of finer particles. The alum is stored in the control room and transported with the help of a dosing pump that delivers a predetermined amount of chemical through flexible tubing. After the alum dosing tank, the water flows into a tertiary filtration tank containing Parkinson's Title 22 Dynadisc filter for removal of the finer solids that were not separated out in the clarifier. The water passes through the Dynadisc filter and the suspended solids are trapped on the outside of the filter media. As the filtration process continues, solids build up on the cloth filter media, restricting the water flow through the filter, and as a result, the water level in the tank rises. When the level reaches a predefined point, the automated backwash cycle begins. During the backwash mode, the vacuum pump is activated and a vacuum head rotates across the surface of the disc. The vacuum head suction ports remove the captured solids from the media. Since only a minimal area of the disc filter is cleaned at one time, the backwash cycle does not disrupt the filtration process. The backwash water is returned to the equalization tank for processing. The treated effluent from the secondary clarifier overflows into chlorine contact tank for disinfection. This tank provides enough retention time for the disinfectant to take effect and reduce the pathogens to the required levels. Chlorine dosing pumps supply the required amount of chlorine to kill pathogens and other harmful organisms in the water. The automated dosing system is located in the control room, and the chlorine is transported through flexible tubing. After the designed retention time, the final discharge will meet all the criteria set forth by the California Title 22 Effluent Standard. The sludge wasted from the clarifier is held in the sludge collection tank. Sludge will be stored and thickened here to approximately 2% solids under aerated conditions. Aeration is provided to keep the sludge in the sludge holding tank aerobic. There is some sludge volume reduction in sludge holding due to the bacteria and other living organisms using their internal energy stores in the absence of other carbon food sources. The advantage of aerobic digestion includes good volatile solids reduction, lower BOD concentrations in supernatant, and an odorless and stable end product. The design and configuration of the sludge storage tank makes it suitable for digesting nutrient-rich biosolids while concentrating the sludge and thus increasing the sludge storage efficiency. The digested sludge must be periodically removed for disposal as liquid slurry. This can be done by emptying the sludge out through the drain pipes with the help of a vacuum truck. Over time, scum and floatables will accumulate on the surface of the sump and collection tanks. When this floating layer is exposed to heat, it will dry up and be difficult to pump. It is strongly recommended to suck this layer out with a vacuum truck every time a vacuum truck comes to haul away the sludge to avoid any inconveniences during rig move time.